So 7th and 8th grade, chapter 1, section 1. It's the same exact thing. It's all about rational numbers, which is helpful. So rational numbers means anything you can write as a ratio. Was Gucci, says Mr. Ellis with 6 S's. Good for him. Alright, ratio. So ratio is just a fraction. Jason Borcher says Afalabi. Good for him. So any fraction is rational if you can write it as a over b, or a and b can be any numbers except b can't be 0 because you cannot divide by 0. Okay? So basically the idea is going from fractions to decimals and decimals to fractions. So we got some examples, so we'll knock this out real quick. So going from fraction to a decimal, you divide, go top in, bottom out, or TBO, which you've probably heard by now. So top in, bottom out. So here's our top number, goes on the inside. Bottom number goes on the outside. 5 cannot go into 3, so we add a decimal, and a 0. Super distracting, like you can watch the people talk. Oh, I don't know if that's big enough to read. Let me know if that's big enough to read. So 5 goes into 30 6 times. And then 6 times 5 is 30. 30 minus 30 is nothing. And we're all done. So 3/5 is equivalent to 0.6. And we've done our first math problem of the year. Hooray. Okay. Five people watching. How about that? Alright, so the next one, 37 out of 50. We can do this the exact same way. So we can say 37 goes on the inside. 50 goes on the outside. 50 can't go into 37, so again we add a decimal, and a 0. This will always be the case if it's a proper fraction, meaning that the top number is less than the bottom number, numerator smaller than the denominator. Will always be 0 point something. So if you want to know if you're doing it the correct way, if it's a proper fraction and it doesn't start with 0 point something, you're backwards. Alright, so 50 goes into 370. That is 7 times. 7 times 50 is 350. 370 minus 350 is 20. We still have more to go, so we add a 0, bring it down. 50 goes into 200 4 times. 4 times 50 is 200. Nothing left over, so there's our answer. We have 0.74. I never got an answer if chat was big enough to read. I just got, I got post notifications on, cuz, spelled wrong, capital K. I'm a math person. Okay, not helpful. So the alternative to dividing all this out is if you recognize that 50 is a factor of 100, we can simply rewrite the fraction. So 37 over 50 is equal to some number over 100, because 50 times 2 is 100. And then we just have to say, what is 37 times 2? And 37 times 2 is 74. Look at this inappropriate name messing up everything. Why is that even allowed on YouTube? I'm putting you in timeout. That didn't. That didn't get rid of your name though, which is the part I wanted to get rid of. Oh well. Alright, we're learning. Alright, so 74 out of 100. is 74 hundredths. That's what we wanted. Okay, third one. So 3 1/5. If you have a mixed number, it's the same idea, except you take the whole number that you started with, and that just becomes part of your answer. So this is going to be 3 point something, whatever 1/5 is. So then we say top in, bottom out. Move this out of the way here. And then 1/5's nice and easy. Hopefully you just know what 1/5 is, and if not, you learn it sometime this year because it'll save you some time. But 5 can't go into 1, but it goes into 10 2 times. So we just get 0.2. So we attach that to our whole number part of the answer, and we get 3.2. That's it. So mixed numbers does not add a whole lot to the process. Well, why does it look all fuzzy? Does it look fuzzy to everybody, or am I getting myself confused here? Oh, all I have is Jason here to help me out, so I will not get any useful answers more than likely. I'll just have to watch it back later. Alright, last one. 7/9. It's a little different because this one will not work out quite as nicely. So it starts out the same way. 7 in, 9 out. And we'll ignore the negative for now. We'll come back to that. So 9 goes into 70 7 times. This is 63. And then we get 7 again. 9 goes into 70 7 times. This is 63. And then we keep adding zeros. And what's happening here is the number we divided previously is the exact same number that came up the next time, and the exact same number that came up again, which means this will keep repeating forever. Only instead of actually doing math forever, we stop wherever it repeats, and we put the little bar notation over it to say that this is 7 repeating. So our decimal part is 0.7 repeating, but then because it's negative, call it negative. There you go. So that's fractions of decimals. A lot of this is knowing your multiplication facts. So if you don't know your multiplication facts, take some time, go learn them. Find yourself some flashcards. All right, the next part is going from decimals back to fractions, and this becomes an exercise in reading and knowing your place value. So in case you forgot your place value, if we say 1, 2, 3, 4, okay, everything after the right of the decimal has place value, and it goes, okay, I can't write sideways, I can barely write frontways today, so let's do this. So 0.1, 2, 3, 4. 1 is in the tenths place. 2 is in the hundredths place. 3 is in the thousandths. And 4 is in the 10 thousandths. 10 thousandths. Okay. And it'll keep going on like that forever. The only thing you have to remember is that there is no ones place. So we start at the tenths. Okay. And then if you want to read a decimal, you just look at the number furthest to the right. So in this case, this is 4. It's in the 10 thousandths place. And then you just read the number. So this is 1,234 10 thousandths. Okay. Or if we wanted a shorter number, like let's say it was just 0.12, well, the last number is in the hundredths place, so it would be 12 hundredths. So all it is, you just remember where your place value is, and then you read it. Okay. So like 0.8, 8 is in the tenths place. So this is just 8/10. Literally 8/10. And there's a negative sign, so we can keep the negative sign. We can simplify this. Since they're both even, we can divide them both by 2. So we get 4/5, still negative. I can't simplify that anymore, so there is our answer. Okay. Next one, 0.44. So this one ends in the hundredths place. So this is 44/100. And then again, we can simplify this. They're both even, so I know I can divide by 2. So that gives me 22/50. And then I can divide that again by 2. So 22 divided by 2 is 11. 50 divided by 2 is 25. I can't simplify this anymore. So this is our final answer. It's really straightforward. As long as you know your place values, these ones are pretty easy. Okay. And then this is where the 7th grade part of this ends. So if you're in 7th grade, you wouldn't have to go any further than this. Really, if you're in 8th grade, you don't have to go any further than this, but there's a couple additional problems in there to make you think a little bit. So let's try them out, because this is pretty fun. Relative. So next one we have is 0.8 repeating. So really what this decimal is 0.88888 forever. Okay. So now the problem is, up here we said figure out what the last, or the number furthest to the right is. That's your place value. But this one, it doesn't ever end. So we need another strategy. So we use some algebra that you probably don't know yet. We're just going to lead you along here. We're going to say x is just some variable equals our decimal. Okay? So x is 0.888 repeating. And then I want another number with the same repeating decimal. Okay? So what we do is we take x, and I'm going to multiply it by 10. Okay? So if I multiply by 10, that moves my decimal over one place. So I end up with 8.88888, and it goes on forever. Okay? The reason we do this, it's another part of algebra you haven't learned yet, but here you go. If you have two equations in the same problem existing at the same time, you can add or subtract them. Okay? And so I'm actually going to switch my order around here. Whoop. So that way I can say I'm going to subtract my bigger numbers from my smaller numbers. So 10x minus 1x is 9x. Okay? And then 8.8 repeating minus 0.8 repeating. The reason we did all this is that now all the decimals will cancel out. So all we're left with is just 8. Right? Because it's like 8 minus 8 is 0. 8 minus 8, 0, 0, 0, 0, all the way through. So all we're left with is just 8. And then I'm just solving for x. So to get x by itself, we do the opposite of what happened before. So to get rid of times 9, we would divide by 9. And we're left with x equals 8/9. So what is 0.8 repeating as a fraction? It is 8/9. Piece of cake, but not really. But it's a fun trick. If you can figure this out, it's not so bad. Alright, so let's try again. Something a little difficult. more difficult. So the same basic idea. We have a number, and we're going to say x equals that number, 4.45. This time we have two numbers repeating, so this would be 4, 5, 4, 5, forever. Okay. So I want to do something. So I end up with some multiple of x, but with the same repeating decimal. So in this case, since the pattern repeats every 2 times the decimal moves over, instead of multiplying by 10, I'm actually going to multiply by 100. So 100 times x is equal to, so this time we're going to move the decimal back 2 places. So let's see. Just move some stuff over so it's a little bit cleaner. So if I move it over 2 places, I would get 445.454545. Still repeating. And then again, I can do math with those two equations. I can subtract one from the other. So 100x minus 1x is 99x. Okay. Again, all these decimals are going to cancel each other out. So all I have left is 445 minus 4, which is just 441. And then I want to get x by itself. So I'm going to divide by 99. So I'm left with x equals, this cancels, 441 over 99. And then we can simplify this, because I know the whole number is 4. So 99 times 4 is 396. And then how many 99s would be left over? So we'd say, what is 441 minus 396? So we're saying all the parts we had total, oops, minus the whole number part of it to get our remainders. So we borrow here. 11 minus 6 is 5. 43 minus 39 is 4. So we end up with 4 as the whole number and 45 99ths. Okay. So now something, hopefully you notice in the 2 examples we did, but maybe not because you've only seen 2 examples, is that almost always, I think it's always, but I don't want to say always because I haven't tried all these, almost always, if you have a repeating decimal, it ends up being that number, right, over some amount of 9s. So like this one here was in the 10ths place, so we had 1 9. This was in the 100ths place, we have 2 9s. But the number that was repeating is in the numerator both times. So if you want to skip a lot of work, you can hope that it's this number, right, over some number of 9s. Maybe it'll work out for you. But then again, this question doesn't actually show up that much in 8th grade. This is just for goofs. Okay. So a couple word problems, and then we're out of here. So use this figure at the right. Write the width of the jelly bean as a fraction. Okay, and then as a decimal. So this involves knowing how to read a ruler, which is a struggle. So we can start off practicing how to read a ruler is counting how many little notches there are between where we started and where we ended. Okay. And now a problem people have counting on a ruler is they forget how to count. Some of them, they'll start here and they'll call this 1. They'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So what happened? Because there are not 17 spaces here. You don't start at 1, right? This is where you begin. 1 is the first place over. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Anytime you're counting on a ruler, your final count should always be some multiple of 2. So either be 2 or 4 or 8 or 16 or 32 if you've got a really fancy ruler. Okay? Because what it does, how a ruler measures things, and why these little bar lengths are different sizes, is like this one here, right in the middle, represents 1/2. This is 1/2 of an inch. And then 1/2 of that, so right here, is 1/4. And then 1/2 of that, right, so right here is 1/8. And then this very last one, you guessed it, is 1/16. So we start at 0 out of 16, and we end up with 16 out of 16, or 1. Okay? Hopefully that makes sense. Or hopefully you knew how to read a ruler before you got here. Okay. So anyways, so here's the fraction we're looking for. It's a little bit past 1/2. So this is 8 over 16. So if it's one more past that, this has to be 9 out of 16. And that is our fraction. Piece of cake. And then we want that as a decimal. So we said to go from fraction to a decimal, we just divide, top in, bottom out. So this number won't come out too nice. Should get 4 decimal places. Let's find out. So 16 can't go into 9. Okay, so we add a 0. 16 goes into 90. Who knows? Who knows? We know it's more than 1/2, so let's try 5. Let's see 0.5 something. So 16 times 5. So this is 30. And then 5 plus 3 is 8. And I definitely can't get another 16 without going over 90. So this is going to be 0.5 something. Okay. 80. 10. And then I'm going to bring down another 0. So how many times can 16 go into 100? Well, 80 was 5 times. So this is probably going to be 6 times. So if I add 16 to 80, I'll get 96. So this is going to be 5, 6. I'm going to run out of room here. That's okay. Okay. So 16 goes into 40. Well, 16 times 2 is 32. I can't go over that. It's going to be 32. And then we get 80. There we go. That's a familiar number. So 16 goes into 80. We figured that out earlier. Is 5 times. So 9/16 is equivalent to 0.5625. And that's it. Normally though, in 8th grade, we'll say round to 2 places. So if you got to 562, we could say, well, 2 will round down. So 9/6 is about 0.56. And that probably would have been good enough here. Okay. Last one. So the last question here checks to see if you know how to tell time. So marathon in 3 hours and 12 minutes, write that as a decimal. So some people will be so happy to say, oh, well, that's 3.12, smiley face, easy, I'm done. And then they'd be wrong. Okay, if it seems too easy, it's because it is. So why is it not 0.12? Because if we're talking about minutes to hours, you have to figure out how many minutes are in 1 hour. And the answer is not 100. So we cannot call this 12 out of 100. This has to be 12 minutes is 12 out of 60 hours. Okay? So really, The time it took him to run the marathon was 3 and 12/60ths of an hour. Okay, so we need to know what is 12/60ths as a decimal. So we can actually, how do we want to do this? Let's just do top and bottom out. We could also simplify 12 out of 60, but this won't be that bad because 60 can't go into 1, it can't go into 12, but it can go into 120 2 times. So 12 out of 60 is 1/5, which was the very, no, it wasn't the first problem. We did 3/5. Ah, close enough. It's 3 and 1/5, and 1/5 is 0.2. So it's 3.2 hours. And we say, oh, but 3.12 hours, that's pretty close. And I say, no, it's not close. This is close. Correct is close. We want correct. Okay? So that's it. We worked on a lot of things. I'm tired of talking now, though. So goodbye.